So hello everybody, I'm Toby Delbrook, and this is a tutorial for the Learning to Control topic area about the Learning to Race simulation framework that we'll use at the 2021 Telluride Neuromorphic Workshop. The idea of this topic area and this particular project area is to develop an algorithm or including neural network that learns to drive a car like this one here around the racetrack using only limited real-time data from trial runs, and you're not allowed to look at the car dynamics model, and you get perfect state, so you don't need to do any perception. And the car model we use, which is considered a simple model but it's hidden from us, is developed by Matthias Althoff and his group who developed the Common Roads package at TU Munich. It's a bicycle model that lumps the two rear wheels together and the two front wheels together. The car has a steering wheel angle, an angle of the car relative to the compass directions, a slip angle across the car body, and so on. From these state variables and parameters, forces and torques are computed in the dynamical equations of the 7 state variables, which are functions of the states and vehicle parameters. The vehicle parameters are contained in a vehicle parameters file, and there are several different vehicles available. We usually use an Audi passenger car, rear-wheel drive passenger car model. And one thing I want to draw your attention to is this minimum steering velocity, which is the rate you can turn the steering wheel. This actually makes steering difficult because it takes time to turn the steering wheel to a new position. If you run L2RACE, you'll see a visualization of all these state variables, including how long it takes the simulation to run. You can see the steering wheel angle here, going at the maximum rate from full left to full right, and the car velocity and other variables such as the slip of the car. And you can replay these parameters and fast forward and rewind for any recording to see what happened in the recording. Our goal in the project is to learn to see if we can learn this hidden model from data and then controlling it using nonlinear model predictive control. The project itself is hosted on GitHub in the Neuromorphs workspace. It's called L2RACE. And the way it works is that it's a client-server architecture. The contestant, which is you, has the map of the track. It gets the state of the car. It computes the control, and then it sends a command by UDP over the network to the server. This is a computer that we run on a blade of the university, and it computes the car model and updates the state, and then it gives back the state to the client, which is you. Your command is then a steering command from -1 to 1, an acceleration from 0 to 1, and a brake from 0 to 1, and the state you get is here. It includes position, velocity of the car, the acceleration of the car along its own body, the distance from the center line of the track, the distance to each edge of the track, the angle of the car to the center line, the next track vertex along the track, and the position on the track as a percentage of the whole race course. So L2RACE includes a number of different tracks. The Oval Easy is the one you should start with because that's challenging by itself. It's specified by the track Oval Easy when in startup. And but besides this Oval Easy track, we also include many other tracks ranging in difficulty all the way up to this quite difficult courses, track 6 and 7, and 5 with these lots of hairpin turns and straightaways. So go for it. Get out your joystick controller and start collecting data from the track, and then join us in our intercontinental tracks races where we go mano a mano against each other, and algorithm against human, and algorithm against algorithm. Looking forward to it. You can see many more tutorials from the 2021 workshop channel on the website.